Far below the surface of the ocean, beyond the reach of sunlight, there is a world that challenges almost everything we think we know about life, physics, and survival. It is colder than most places on Earth, darker than the deepest night, and under pressures so immense they would crush most familiar forms of matter. And yet, this hidden realm exists quietly beneath our feet, covering more than half of the planet. When people imagine extreme environments, they often look upward. They think of the vacuum of space, the cold emptiness between stars, or the radiation-filled surfaces of distant planets. Space feels hostile, vast, and unforgiving. It feels like the ultimate test of endurance. But the deep sea may be even more extreme. Not louder, not more violent, just more absolute. As you descend through the ocean, conditions change slowly at first. Light fades, colors disappear. The water grows colder, heavier, denser. Then, at a certain depth, the environment crosses a threshold. Sunlight no longer reaches. Photosynthesis becomes impossible. The surface world, with its storms and seasons, effectively ends. What remains is a place defined by pressure. For every 10 meters you descend, the weight of the water above you increases. By the time you reach the deep sea, that pressure has multiplied hundreds of times over. At the deepest points, the force pressing in from all directions is so great that it would instantly collapse unprotected human lungs, shatter bones, and crush most machinery ever built. And yet life exists there, not clinging desperately, not barely surviving, but thriving in ways that seem almost impossible. This is what makes the deep sea so unsettling to study. It does not merely lack the conditions we associate with life, it actively opposes them. There is no light, almost no heat, no easy energy source, and pressure that defies intuition. In space there is emptiness. In the deep sea there is weight. Space kills by absence. The deep sea challenges life by excess. In the vacuum of space, molecules drift apart. In the deep sea they are forced tightly together. Chemical reactions behave differently. Proteins fold in unfamiliar ways. Cell membranes must remain flexible without tearing. Every biological process must be re-engineered for a world that never relents. This is not a place where life should exist by accident. And yet evolution has found ways. The deep sea is not just one environment. It is a layered world stacked vertically, and each zone more extreme than the last. With every kilometer downward, conditions become more alien. Temperature drops toward freezing. Pressure climbs relentlessly. Food becomes scarce. Time itself seems to slow, measured in centuries rather than days. Creatures here do not rush. They conserve. They wait. Some live for decades, even centuries, growing slowly in the darkness. Others rely on chemistry instead of sunlight, drawing energy from minerals and heat rising from the planet's interior. Entire ecosystems exist without any connection to the surface world at all. This is one of the first ways the deep sea surpasses space in extremity. Space is empty, but predictable. Its rules are clean and simple. The deep sea is crowded with constraints layered on top of one another. Pressure, darkness, cold, and isolation all act at once, without pause. And unlike space, the deep sea is not far away. It is here, right now, beneath the waves. Most of it has never been seen by human eyes. We have mapped more of the surface of Mars than the ocean floor of our own planet. The vast majority of deep-sea environments remain unexplored, known only through indirect measurements and fleeting glimpses from robotic probes. This ignorance is not due to lack of curiosity, it is due to difficulty. Reaching the deep sea requires machines strong enough to resist crushing pressure, sensitive enough to operate in darkness, and reliable enough to survive in an environment where repair is impossible. Every expedition is a balance between engineering limits and the ocean's indifference. And still, when we do look, what we find challenges assumptions. Life here does not resemble surface life scaled down. It is fundamentally different. Bodies are soft where ours are rigid. Bones are reduced or absent. Fluids replace air. Structures that would collapse on land remain stable under pressure. The deep sea forces biology to abandon familiar designs. In space, we imagine life protected by suits, stations, and shields. In the deep sea, life is shaped from the inside out by its environment. It does not resist pressure, it embraces it. This distinction matters because it reveals something profound about life itself. Life is not fragile in the way we often think. It is adaptable beyond comfort, beyond familiarity, and beyond the environments we instinctively fear most. The deep sea shows us that extremity is relative. An environment that would destroy us in seconds can be home to creatures that have never known anything else. To them, the crushing pressure is not hostile. It is normal. It is stabilizing. It is part of the structure of existence. This inversion of perspective is one of the quiet lessons of the deep ocean. What feels extreme depends on where you begin. As we continue, we will descend further into this world, layer by layer. We will examine how pressure reshapes biology, how darkness rewrites sensory systems, and how life persists where energy itself seems scarce. We will see why some deep-sea creatures would not survive at the surface, just as surely as we would not survive below, and slowly, calmly, we will come to understand why the deep sea may be the most extreme environment on Earth, more demanding than space, more alien than distant planets, and yet deeply, unmistakably alive. Pressure that rewrites the rules of life. Pressure is easy to ignore on the surface. Air presses on us constantly, yet we do not feel it. Our bodies are adapted to it so completely that it fades into the background of experience. But pressure does not disappear as you descend into the ocean. It accumulates. Layer after layer, it builds until it becomes the defining feature of the deep sea. By the time you reach a depth of 1,000 meters, the pressure is already 100 times greater than at the surface. At the deepest trenches, it exceeds 1,000 times atmospheric pressure. This is not just a difference in degree, it is a difference in kind. Under these conditions, familiar materials behave differently. Gases compress into liquids. Structures that seem solid become fragile. Even chemical reactions are altered. Pressure does not merely squeeze objects. It changes the rules under which matter operates. For life, this creates an extraordinary challenge. On land, most organisms rely on rigid structures. Bones, shells, and stiff tissues provide support against gravity. In the deep sea, gravity is no longer the main problem. Pressure is. Rigid structures tend to crack or collapse when forces act on them from all directions at once. As a result, many deep-sea creatures are soft-bodied. Their tissues are flexible, allowing pressure to pass through them rather than resist it. Instead of fighting compression, they allow themselves to be compressed evenly. This is a fundamental shift in design. Air-filled spaces are especially dangerous under pressure. Lungs, swim bladders, and cavities that work well near the surface become liabilities at depth. Deep-sea animals often lack these spaces entirely. Where buoyancy is needed, it is achieved through oils or gelatinous tissues that do not compress easily. Even at the cellular level, pressure forces adaptation. Proteins must fold correctly to function. Under high pressure, the forces that hold proteins together weaken. Enzymes can lose their shape. Chemical reactions can slow or fail entirely. To survive, deep-sea organisms produce specialized proteins that remain stable under crushing force. Cell membranes face similar challenges. They must stay fluid enough to function without becoming leaky or rigid. Deep-sea species alter the composition of their membranes, using specific fats that remain flexible at high pressure and low temperature. These are not small adjustments, they are fundamental redesigns. Pressure also affects metabolism. Reactions that proceed easily at the surface may require more energy in the deep. As a result, many deep-sea animals have slower metabolisms. They move less. They eat infrequently. Some species can survive long periods without food, conserving energy in a world where resources are unpredictable. Time itself seems to stretch in the deep sea. Growth is slow. Reproduction may occur only occasionally. Some deep-sea fish live for decades, their lives unfolding at a pace that would feel almost motionless to surface dwellers. This slowness is not weakness, it is efficiency. The deep sea rewards patience. It favors systems that minimize waste and endure long intervals between opportunities. Sudden bursts of activity are rare and costly. Survival depends on stability. Pressure even influences how animals sense their environment. Sound travels differently under pressure. Light, where it exists at all, behaves unpredictably. Many deep-sea animals rely less on vision and more on chemical and mechanical senses. They detect subtle vibrations, faint chemical trails, and minute changes in water movement. Some produce their own light, not for illumination, but for communication, camouflage, or luring prey. Bioluminescence becomes a language in the darkness, shaped by pressure and scarcity. In space, organisms face radiation, temperature extremes, and vacuum. These are serious challenges, but they are intermittent. Space is often empty and forgiving in its emptiness. The deep sea offers no such relief. Pressure never turns off. There is no shelter from it. No pocket where it fades. It presses constantly, evenly, without pause. Every moment of existence is shaped by it. And yet deep-sea life does not merely endure this pressure, it depends on it. Bring many deep-sea creatures to the surface and they die not from lack of pressure but from its absence. Their bodies are built for compression. Without it, tissues expand, structures fail, and life unravels. This reversal is striking. The environment that would kill us becomes essential to them. The force we fear becomes their foundation. Pressure in the deep sea is not an enemy. It is a condition of being. Understanding this changes how we think about extreme environments. It reminds us that extremity is not absolute. It is relative to design, adaptation, and history. As we continue deeper, pressure will remain a constant presence. But darkness, cold, and scarcity will begin to play equally important roles, because pressure alone does not define the deep sea. It is the combination of forces acting together that makes this world more extreme than space. Darkness that reshapes perception. If pressure is the weight of the deep sea, darkness is its atmosphere. Below a certain depth, sunlight does not fade gradually. It ends. One moment light exists, the next it does not. This boundary is not symbolic, it is physical. At roughly 1,000 meters below the surface, the last scattered photons from the sun are absorbed. Beyond this point, there is no natural light at all. The deep sea is not dim, it is perfectly dark. This darkness is not like night on land. There is no moonlight, no starlight, no distant glow on the horizon. The water absorbs everything. Blackness is complete and uninterrupted, stretching for kilometers in every direction, and yet life continues. To understand why the deep sea may be more extreme than space, it helps to understand what absolute darkness does to perception, biology, and behavior. In space, darkness is common, but it is not isolating in the same way. Light travels freely in a vacuum. Stars are visible across vast distances. Orientation is possible. Reference points exist. In the deep sea, darkness is enclosing. Light cannot travel so far. Even artificial light from submersibles is swallowed within meters. Beyond the beam there is nothing. No visual context, no sense of scale, just blackness pressing in from all sides. This changes everything. Vision, one of the most dominant senses on the surface, becomes unreliable or unnecessary. Eyes, when they exist at all, must be radically redesigned. Some deep-sea animals have enormous eyes, sensitive enough to detect the faintest traces of bioluminescence. Others abandon vision entirely, saving energy by letting eyes shrink or disappear. In a world without sunlight, seeing becomes optional. But darkness does not mean absence of information. It means information must travel differently. Sound, vibration, and chemistry take over. Water is an excellent medium for transmitting vibrations. In the deep sea, subtle movements travel far. A distant fin stroke, a shifting current, the faint pulse of a swimming organism can be detected through specialized sensory systems. Many deep-sea fish possess lateral lines so sensitive they can feel the movement of nearby creatures without ever seeing them. These systems detect pressure changes in the water itself, turning the surrounding ocean into a living map. Chemical signals also become crucial. Scents linger in the still, cold water. A trace of food, a reproductive signal, or the presence of danger can be detected long after its source has passed. In this way, the deep sea becomes a place of invisible communication. Darkness also rewrites the rules of camouflage. On the surface, camouflage relies on blending with colors, patterns, and light. In the deep sea, where there is no ambient light, camouflage means something else entirely. It means not being seen when light suddenly appears. This is where bioluminescence becomes one of the most fascinating adaptations in all of biology. Many deep-sea creatures produce their own light. This light is not bright. It is controlled, subtle, and purposeful. Some use it to lure prey, dangling glowing appendages in the darkness. Others use it to communicate, flashing species-specific signals that only the right eyes can detect. Some use light defensively, creating sudden bursts to confuse predators or releasing glowing clouds that allow them to escape unseen. Perhaps most remarkable is counter-illumination. Certain animals produce light on their underside that matches the faint glow filtering down from above. To a predator looking upward, the animal's silhouette disappears. It becomes invisible, not by hiding, but by perfectly balancing light. This level of precision is only possible in a world where light is rare and valuable. Darkness also influences behavior. In the deep sea, movement is expensive. Every motion costs energy, and energy is scarce. Many animals drift slowly, conserving strength. Others remain motionless for long periods, waiting for food to come to them. Predation itself changes. On the surface, predators often rely on speed and pursuits, or pursuit. In the deep sea, ambush becomes more common. Large mouths, expandable jaws, and flexible stomachs allow animals to consume prey nearly their own size, because the next meal may be far away in both space and time. This is another way the deep sea exceeds space in extremity. In space, resources are rare, but interactions are infrequent. In the deep sea, life is surrounded by potential life, yet encounters are unpredictable. Darkness isolates individuals even when they are physically close. This creates a strange paradox. The deep sea is crowded, yet lonely. Organisms may live their entire lives without ever encountering another of their kind except briefly, perhaps only once for reproduction. To survive this, many species produce vast numbers of offspring, trusting probability rather than proximity. Others develop long lifespans, extending the window during which such encounters might occur. Darkness also affects time perception. Without light cycles, there is no day or night, no sunrise, no sunset. Circadian rhythms, so fundamental to surface life, lose their meaning. Some deep-sea species maintain internal clocks, possibly inherited from surface ancestors. Others appear to operate without clear daily cycles at all. Time becomes less segmented. This contributes to the deep sea's sense of stillness. Life unfolds without obvious markers. Changes occur, but slowly, quietly, without external cues. In space, astronauts rely on artificial light cycles to maintain mental health. In the deep sea, life has adapted to the absence of cycles entirely. This adaptation goes beyond physiology. It shapes ecosystems. Entire food webs operate without sunlight. Instead of plants capturing energy from the sun, the deep-sea ecosystems often rely on marine snow, a slow, constant rain of organic debris drifting down from the surface. Dead plankton, waste particles, fragments of life fall through the water column, feeding organisms far below. This rain is sparse and unpredictable. As a result, deep-sea animals must extract maximum value from minimal input. Some ecosystems go even further. At hydrothermal vents, life bypasses the surface world entirely. Here, energy comes from the Earth itself. Chemicals released from the planet's interior fuel bacteria that form the base of complex ecosystems. Worms, clams, and crustaceans thrive without ever seeing sunlight, without any connection to photosynthesis. This is perhaps the most striking comparison to space. We often search for life beyond Earth by looking for sunlight, warmth, and liquid water. The deep sea shows that life does not require light at all. It requires energy gradients, differences that can be exploited. Darkness, then, is not a barrier to life. It is a condition that reshapes it. But darkness also imposes psychological strain on human explorers. Submersible pilots describe the deep sea as more unsettling than space. In orbit, Earth is visible, the stars are visible, there is orientation. In the deep sea, there is only the immediate surroundings illuminated by artificial light, and beyond that, nothing. The sense of enclosure is intense. Pressure presses inward. Darkness removes distance. Sound behaves strangely. Even experienced explorers describe the deep sea as claustrophobic despite its vastness. This emotional response hints at something deeper. Humans evolved in light. Our senses, our instincts, our sense of safety are all tied to visibility. Darkness removes reassurance. It makes threats unknowable, even when none are present. Deep-sea life evolved without this bias. For them, darkness is not absence. It is normal. This difference in perception is another reason the deep sea feels more extreme than space. Space is unfamiliar, but it still aligns with some human expectations. Emptiness, distance, silence. The deep sea violates expectations more completely. It surrounds, presses, and hides. And yet life has not only adapted, but specialized, diversified, and stabilized in this environment. This challenges a common assumption about extremity. We often think the most extreme environments are those furthest from Earth's surface, but the deep sea is part of Earth. It is not alien in origin, it is alien in condition. It exists not because Earth is gentle, but because Earth is complex. Darkness, when combined with pressure, cold, and scarcity, creates an environment that filters out anything unable to adapt completely. Partial solutions do not work here. Life must be fully integrated with its surroundings. This makes deep-sea organisms some of the most specialized forms of life known. They are not survivors in spite of darkness. They are products of it. As we continue deeper into the deep sea's story, we will see how cold, isolation, and energy scarcity add further layers of extremity, and how life continues to respond quietly and precisely to conditions that would seem impossible anywhere else. Because pressure and darkness are only the beginning, cold, isolation, and the economy of energy. If pressure is the force that shapes the deep sea and darkness is the condition that defines it, then cold is the quiet constant that governs everything else. Cold slows reactions, conserves motion, and stretches time. In the deep ocean, cold is not a temporary state, it is permanent. Below the sunlit layers, the temperature of the ocean drops rapidly. Within a few hundred meters, warmth disappears. In much of the deep sea, temperatures hover just above freezing, often remaining between 1 and 4 degrees Celsius. This cold does not fluctuate with seasons, it does not respond to weather. It is stable, unchanging, and relentless. This stability might sound gentle, but biologically it is demanding. Cold slows chemistry. Chemical reactions that proceed easily at warmer temperatures become sluggish. Enzymes work less efficiently. Metabolism slows. Growth stretches over years instead of weeks. Reproduction becomes infrequent and costly. For surface life, cold is often a challenge to be endured temporarily. For deep sea life, cold is the baseline. This fundamentally changes how energy is used. On the surface, energy is abundant. Sunlight fuels photosynthesis. Food webs are dense and dynamic. Many organisms live fast lives, growing quickly, reproducing often, and dying young. Energy flows rapidly through these systems. In the deep sea, energy is scarce. There is no sunlight, no plants, no easy entry point for energy. What little energy arrives must travel long distances, often in the form of marine snow, a slow rain of organic material drifting down from the surface. By the time it reaches the deep sea, much of its energy has already been consumed. What remains is thin, inconsistent, and unpredictable. This scarcity forces a different strategy. Deep sea organisms live in what could be called an economy of patience. Every movement costs energy. Every decision matters. Waste is minimized. Excess is avoided. Survival depends not on speed, but on efficiency. This is one of the key reasons the deep sea may be more extreme than space. In space, resources are sparse, but organisms brought there are protected by technology. Life in space relies on constant external support. In the deep sea, life must be self-sustaining with no intervention and no rescue. Cold amplifies this challenge. At low temperatures, muscles contract more slowly. Nerves transmit signals less efficiently. Reaction times lengthen. For predators, this makes chasing prey impractical. For prey, it makes constant vigilance impossible. The solution is not to fight the cold, but to work with it. Many deep-sea animals move slowly, deliberately. Some drift almost motionless, conserving energy and waiting for opportunities rather than seeking them. Others rely on ambush strategies, minimizing movement until the moment it matters. Still others adopt a strategy of extreme flexibility. Expandable jaws and stomachs allow certain fish to consume prey nearly as large as themselves. This may seem excessive, but it reflects the reality of deep-sea life. When food is rare, you cannot afford to be selective. You must be prepared to capitalize fully on rare encounters. This approach contrasts sharply with surface ecosystems, where specialization often means efficiency. In the deep sea, specialization often means versatility. Cold also affects reproduction. Producing offspring requires significant energy. In environments where energy is limited, reproduction becomes a carefully timed event. Some deep-sea species reproduce only occasionally, releasing larvae that drift upward or outward, spreading across vast distances. Others employ more unusual strategies. In some species, males are tiny compared to females and exist primarily to provide genetic material. In extreme cases, Males fuse permanently to females, becoming parasitic providers of sperm. This ensures reproduction in a world where finding a mate may be the greatest challenge of all. This strategy may seem extreme, but it reflects the isolation of the deep sea. Isolation is not just physical distance, it is ecological separation. Even though the ocean is continuous, the deep sea is fragmented by depth, temperature, pressure, and chemistry. Two organisms may be only kilometers apart horizontally, yet separated by environmental barriers that make interaction impossible. As a result, deep sea populations are often sparse and widely dispersed. This isolation shapes evolution. Traits that might be disadvantageous on the surface, slow growth, delayed reproduction, low mobility, become strengths in the deep sea. Stability is rewarded. Persistence matters more than speed. Cold also preserves. Organic material decomposes more slowly at low temperatures. This means that when food does arrive, a fallen whale, a sinking tree, a mass of organic debris, it can support life for years or even decades. These rare events become temporary oases in an otherwise sparse environment. Entire communities form around such falls. Whale falls, in particular, are among the most remarkable deep-sea phenomena. When a whale dies and sinks to the ocean floor, its massive body delivers an enormous amount of energy to the deep sea. Scavengers arrive first, consuming soft tissue. Then bacteria break down bones, releasing chemicals that fuel entire ecosystems. These communities can persist for decades, supporting species found nowhere else. This highlights another way the deep sea exceeds space in extremity. In space, life support systems are designed to maintain constant conditions. In the deep sea, conditions are stable most of the time, but punctuated by rare, dramatic events. Life must be prepared for long periods of scarcity followed by sudden abundance. This unpredictability further enforces energy conservation. Cold also influences how long deep-sea organisms live. Many species have exceptionally long lifespans. Some deep-sea fish are believed to live for over a century. Certain corals grow so slowly that they may be thousands of years old. These organisms experience time differently. Their lives are not measured in seasons or years, but in geological rhythms. Change comes slowly. Stability dominates. In such an environment, patience is not a virtue. It is a requirement. Isolation and cold together create a world that feels detached from the surface. Surface events, storms, climatic shifts, even mass extinctions, take time to reach the deep sea if they reach it at all. This insulation can protect deep sea ecosystems, but it can also make them vulnerable. When change does arrive, organisms adapted to stability may struggle to respond quickly. This is a growing concern in the modern world. Human activity is beginning to affect even the deepest parts of the ocean. Pollution, warming, and changes in surface productivity alter the slow rain of energy reaching the deep sea. Because deep sea life is adapted to narrow conditions, even small changes can have large effects. This reminds us that extremity does not imply invulnerability. The deep sea is resilient but not infinite. Cold, pressure, darkness, and scarcity have shaped life into forms of remarkable efficiency. But those forms are finely tuned. They depend on the deep sea remaining what it has always been: cold, dark, stable, and quiet. In space, human presence is obvious. In the deep sea, human influence is subtle but spreading. This adds a final layer of extremity. The deep sea is extreme not only in its physical conditions, but in how delicately balanced its ecosystems are. Here has optimized itself for a narrow range of possibilities. There is little room for error. This is perhaps the deepest contrast with space. Space is empty. The deep sea is full but fragile. And yet, despite cold that slows chemistry, isolation that separates individuals, and energy scarcity that demands efficiency, life persists. Not dramatically, not loudly, quietly. The deep sea does not announce its survival, it simply continues. As we descend further into understanding this world, we will examine how isolation and distance shape not just individual organisms, but entire ecosystems, and how the deep sea's separation from the surface makes it one of the most mysterious and extreme environments on Earth. Because cold and scarcity are only part of the story, isolation itself may be one of the greatest challenges life has ever solved. Isolation, distance, and a world cut off from itself. In the deep sea, isolation is not an accident of geography. It is a defining condition of existence. Even though the ocean is one continuous body of water, the deep sea functions as a collection of separate worlds, layered vertically and fragmented by chemistry, temperature, and pressure. Distance here is not measured only in kilometers, it is measured in accessibility. On the surface, movement connects ecosystems. Currents carry nutrients, organisms migrate, and energy flows rapidly from one place to another. In the deep sea, movement is slow, restricted, and often one-directional. What arrives from above may take months or years to reach the depths, and what exists below may never return to the surface at all. This creates a profound sense of separation. A deep-sea organism is not just far from land, it is far from almost everything else. Encounters are rare, interactions are infrequent. The ocean may be vast, but from the perspective of an individual creature, it can feel empty. This isolation shapes biology in subtle but powerful ways. One of the most immediate consequences is population density. In many deep-sea environments, organisms are spread thinly across enormous areas. Where a coral reef might contain thousands of individuals within a small space, the deep sea may hold only a few scattered organisms across kilometers of seafloor. This sparsity changes the rules of survival. Finding food is difficult. Finding a mate can be even harder. For some species, reproduction depends less on timing and more on chance. Larvae may drift for years before settling, carried by currents to places their parents will never see. In such a system, local extinction can be permanent. If a population disappears from a region, there may be no nearby source to replenish it. Isolation turns every habitat into a fragile island. This island-like nature of the deep sea is one reason it remains so poorly understood. Sampling one area tells us very little about another. Two locations separated by depth or chemistry may host entirely different communities, even if they are geographically close. Isolation also drives specialization. When movement is limited and conditions are stable, organisms evolve to fit their environment precisely. There is little advantage to flexibility if conditions rarely change. Over time, this leads to species that are exquisitely adapted to narrow niches. Some deep-sea organisms can tolerate only a small range of pressure or temperature. Others depend on very specific chemical conditions. Hydrothermal vent species, for example, rely on precise mixtures of minerals and heat. Move them even a short distance away from their vent system, and they cannot survive. This level of specialization would be risky in a dynamic environment. In the deep sea, stability makes it viable, but stability comes at a cost. When change does occur, deeply specialized organisms have few options. They cannot migrate easily. They cannot adapt quickly. Evolution in the deep sea often favors endurance over innovation. This makes the deep sea feel frozen in time, even though it is not. Isolation also alters how ecosystems are structured. On the surface, food webs are complex and interconnected. Many species occupy overlapping roles. In the deep sea, food webs are simpler but more fragile. Remove one component and the effects can ripple outward. A single food source can support an entire community. A single whale fall can sustain life for decades. A single vent system can host species found nowhere else on Earth. These ecosystems are not redundant, they are singular. This again sets the deep sea apart from space. In space, isolation is absolute, but life there would be artificial, sustained by constant intervention. In the deep sea, isolation is natural and permanent. Life must function without support, repair, or rescue. Even communication is affected. Signals travel slowly. Light fades instantly, sound carries, but interpretation is limited. Chemical signals disperse gradually. There is no rapid exchange of information across distance. For many deep-sea organisms, the world may feel static. Change happens, but slowly and locally. There are no distant warnings, no early signs of approaching events. Survival depends on responding to what is immediately present. This reinforces conservative behavior. Energy is conserved, risks are minimized, novelty is avoided. The deep sea rewards consistency. Isolation also influences how deep sea species evolve over long timescales. Because populations are separated, genetic exchange is limited. Over time, this leads to high levels of endemism. Many deep-sea species exist only in very specific locations. Entire lineages may be confined to a single trench, ridge, or basin. This hidden diversity is one of the deep sea's greatest mysteries. We know that the deep sea covers most of the planet. We know that it contains countless habitats, and yet the vast majority of species living there have never been described. This is not because they are rare, it is because they are unreachable. Every deep-sea expedition reveals new forms of life, creatures unlike anything seen before, structures, behaviors, and strategies that challenge existing categories. Isolation has allowed evolution to explore paths that surface life never could. This is another way the deep sea surpasses space in extremity. Space is empty and uniform. The deep sea is varied and complex but hidden. Its extremes are not obvious. They are layered, cumulative, and subtle. Even the physical structure of the deep sea reinforces isolation. Mountain ranges, trenches, and plains carve the seafloor into distinct regions. Chemical gradients form invisible barriers. Differences in oxygen concentration, salinity, and mineral content create boundaries as real as walls. An organism adapted to one deep-sea environment may be unable to cross into another, even if the distance is small. This fragmentation creates a mosaic of worlds stacked beneath the surface. From above, the ocean appears continuous. From within, it is divided. Isolation also affects how deep-sea organisms respond to disturbance. On the surface, ecosystems often recover through migration and recolonization. In the deep sea, recovery can take centuries if it happens at all. Growth is slow, reproduction is infrequent, replacement is uncertain. This makes deep-sea ecosystems extremely sensitive to disruption. Human activities such as deep-sea mining, bottom trawling, and pollution introduce changes faster than these systems can respond. A single disturbance can erase communities that took thousands of years to form. This vulnerability is easy to overlook because the deep sea feels distant and abstract. But isolation magnifies impact. In space, damage is localized. In the deep sea, damage can be permanent. Isolation also shapes how deep-sea organisms interact with time. Without regular cycles, without frequent interactions, without rapid change, time becomes diffuse. Events are rare. Waiting dominates. A deep-sea creature may encounter food only a few times a year. It may reproduce only once or twice in a lifetime. Life becomes less about progression and more about persistence. This challenges our surface-based intuitions. We often associate life with activity, growth, and movement. The deep sea shows that life can also be about stillness, patience, and endurance. This does not make it less alive. It makes it differently alive. Isolation strips away excess. It reveals what is essential. Energy use must be efficient. Structures must be resilient. Behavior must be precise. There is no room for waste. In this sense, the deep sea is not just extreme, it is refined. Every adaptation is purposeful. Every feature serves survival under conditions that do not forgive mistakes. This refinement is why deep sea organisms often appear alien. They are not halfway adaptations. They are complete solutions to a specific problem. The problem of existing in a world that is cold, dark, crushing, and alone. Space is often described as hostile because it lacks what life needs. The deep sea is hostile because it demands everything life has to offer. And yet life meets that demand. Isolation, rather than preventing life, has shaped it into forms of remarkable efficiency and resilience. The deep sea is not empty because it is extreme. It is extreme because it is full of constraints that life has learned to navigate. As we move forward, we will explore how these isolated systems connect, how energy and matter move through the deep ocean despite separation, and how the deep sea remains linked, quietly and indirectly, to the rest of the planet. Because even the most isolated world is never entirely alone. And understanding those hidden connections may be the final piece in understanding why the deep sea stands as one of the most extreme environments known, more demanding than space and more alien than distant worlds, and yet inseparably part of Earth itself. Energy without sunlight. On the surface of Earth, almost every form of life traces its existence back to the sun. Sunlight powers photosynthesis. Plants grow, animals eat plants or eat other animals that eat plants. Energy flows outward from a single distant source, warming the planet and fueling nearly all biological activity. In the deep sea, that chain breaks. Sunlight never arrives. Photosynthesis is impossible. The familiar foundation of life simply does not exist. And yet life continues, and not as an echo of the surface world, but as something fundamentally independent from it. This is where the deep sea becomes truly more extreme than space. In space, life would need to bring its energy with it. Every ecosystem would depend on external input, carefully regulated and artificially maintained. In the deep sea, life has learned to extract energy directly from the planet itself. This shift changes everything. At hydrothermal vents, cracks in the seafloor release superheated water rich in minerals from Earth's interior. These fluids can reach temperatures far hotter than boiling water at the surface, yet they do not boil under the immense pressure of the deep ocean. Instead, they mix slowly with the near-freezing surrounding water, creating steep chemical gradients. These gradients are energy. Certain bacteria can exploit them, using chemical reactions instead of sunlight to produce organic matter. This process, known as chemosynthesis, forms the base of entire ecosystems that have no dependence on the sun at all. Here, energy comes from rock, heat, and chemistry. Around these vents, life flourishes in stark contrast to the surrounding seafloor. Tube worms grow several meters tall. Clams and mussels cluster in dense fields. Crabs, shrimp, and fish gather where heat and chemicals provide a rare abundance of energy. These communities feel almost impossible. They exist in total darkness, under crushing pressure, surrounded by toxic chemicals, yet they are among the most productive ecosystems in the deep sea. Life here does not merely survive, it concentrates. This concentration reveals something profound about extremity. The most extreme environments are not always the emptiest. Sometimes they are the most sharply defined. Hydrothermal vents create boundaries so steep that a few meters can mean the difference between life and death. Temperature drops abruptly, chemistry shifts, conditions change faster than organisms can tolerate. As a result, vent life is intensely localized. Move too far from the vent and energy disappears. Move too close and heat becomes lethal. Life exists in a narrow band between extremes. This is a recurring pattern in the deep sea. Energy arrives unevenly. When it does, life gathers tightly around it. When it disappears, the surrounding environment returns to scarcity and stillness. Cold seeps offer another example. Here, hydrocarbons like methane leak slowly from the seafloor. Again, bacteria use chemistry instead of light to produce energy. Again, entire ecosystems form around these invisible flows. These systems can persist for thousands of years, quietly supporting life in a way that surface ecosystems rarely do. There are no seasons, no storms, no sudden changes, just a slow, steady exchange between Earth's interior and the ocean above. This stability allows specialization to deepen. Many vent and seep organisms rely on symbiotic relationships with bacteria. The bacteria live inside their tissues, producing food in exchange for shelter and access to chemicals. The host becomes both organism and ecosystem. This level of integration is rare on the surface. It reflects how extreme conditions compress biological roles. There is no room for inefficiency. Every component must contribute directly to survival. Energy without sunlight also reshapes the broader deep-sea environment. Even away from vents and seeps, life depends on long-distance energy transfer. Organic material produced near the surface drifts downward, fragmenting as it falls. By the time it reaches the abyss, it is scarce and degraded. This creates a gradient of dependence. The deep sea is connected to the surface, but indirectly. Events at the surface, plankton blooms, climate shifts, changes in productivity, ripple slowly downward, influencing life thousands of meters below. But the connection is delayed. A change at the surface may take months or years to affect the deep sea. This delay further insulates deep-sea ecosystems from rapid change, reinforcing stability while increasing vulnerability to long-term trends. This delayed coupling is another way the deep sea exceeds space in extremity. In space, isolation is immediate. In the deep sea, isolation is gradual. Effects propagate slowly, invisibly, often unnoticed until they accumulate. Energy scarcity also forces unusual feeding strategies. Many deep-sea animals are opportunistic feeders. They consume whatever arrives, whether living or dead. Some feed on detritus, others scavenge. Some combine multiple strategies, switching roles as conditions allow. Rigid food chains give way to flexible networks. This flexibility is not abundance-driven, it is survival-driven. When energy is unpredictable, specialization must be balanced with adaptability. Deep-sea life walks this narrow line carefully. Energy limitations also influence size. Some deep-sea animals grow very large, contrary to intuition. In certain environments, large size allows greater energy storage, longer survival without food, and reduced predation. In others, small size minimizes energy requirements. Both strategies can work depending on context. This variability underscores a key point. The deep sea is not one extreme environment. It is many, layered and overlapping. Each zone has its own energy rules, its own constraints, and its own solutions. What unites them is the absence of sunlight. Without the sun, life must rely on patience, chemistry, and long timescales. Growth slows, interactions become rare, efficiency becomes everything. This makes deep-sea life fundamentally different from surface life. It is not built for speed, it is built for endurance. And endurance in a world defined by cold, pressure, darkness, and isolation is perhaps the most extreme adaptation of all. As we continue, we will look at how these energy-limited systems influence the structure of the entire planet, how the deep sea interacts with Earth's chemistry, climate, and long-term stability. Because the deep sea is not just an isolated environment, it is a hidden engine. And understanding how energy moves through it may be the key to understanding why this quiet, crushing, sunless world rivals, and perhaps exceeds, space in its extremity. A world that changes almost not at all. One of the most difficult aspects of the deep sea to understand is not what happens there, but how little happens at all. Compared to the surface, the deep ocean is astonishingly stable. Temperature barely changes, light never appears, pressure remains constant. Storms, seasons, and weather do not reach these depths in any direct way. This stability is not gentle, it is absolute. On the surface, life evolves in response to frequent change. Day follows night, seasons shift, environments fluctuate. These cycles drive adaptation, flexibility, and resilience. In the deep sea, cycles vanish. Change becomes rare and slow. This absence of change is itself an extreme condition. Evolution still occurs, but it unfolds on long timescales. Without frequent disturbances, there is little pressure to adapt quickly. Instead, selection favors traits that work reliably over centuries. Deep-sea organisms often look ancient not because they are unchanged, but because their environment rewards continuity. This leads to what feels like a frozen world. Some deep-sea species resemble forms known from fossils millions of years old. Their designs persist not because evolution stopped, but because it had little reason to alter what already worked. In a stable environment, innovation can be risky. Stability also shapes behavior. Deep-sea animals rarely experience sudden threats. Predators are uncommon, encounters are infrequent. This reduces the need for rapid escape responses or aggressive defenses. Many organisms rely on camouflage, stillness, or chemical deterrence rather than speed. Movement is minimal, action is deliberate. This calm is deceptive, because when change does occur, it can be catastrophic. A shift in oxygen levels, a change in chemical composition, a disturbance of the seafloor. Deep-sea organisms are often poorly equipped to respond quickly. Their systems are optimized for constancy, not disruption. This makes the deep sea both resilient and fragile at the same time. Resilient to short-term variation, fragile in the face of long-term change. This duality sets it apart from space. Space is harsh, but predictable. Its dangers are constant and obvious. The deep sea appears calm, but its balance is delicate. Life here walks a narrow path between survival and collapse. Stability also influences how deep-sea ecosystems store history. On the surface, environments are continually reshaped. Evidence of past events is often erased. In the deep sea, change is slow enough that records accumulate. Sediments settle gently layer by layer, preserving chemical and biological information over millions of years. The deep ocean floor acts as an archive. Within its sediments are records of ancient climates, mass extinctions, volcanic eruptions, and shifts in ocean chemistry. These records remain undisturbed precisely because the deep sea is so stable. This archival role connects the deep sea to the broader story of Earth. While life on the surface responds quickly to change, the deep sea remembers. It preserves signals long after surface systems have moved on. In this way, the deep ocean becomes a long-term memory for the planet. This memory is not passive. Chemical exchanges between the deep sea and the rest of the ocean influence atmospheric carbon dioxide levels, regulate oxygen, and affect climate over geological timescales. The deep sea absorbs heat, stores carbon, and moderates change. These processes operate slowly, quietly, and persistently. They do not make headlines, but without them, Earth would be a far more volatile place. This highlights another way the deep sea surpasses space in extremity. Space is external. It surrounds Earth. The deep sea is internal. It is part of the planet's regulatory system. Its stability is not incidental, it is functional. Life in the deep sea participates in this regulation. Microorganisms play a major role in carbon cycling, nutrient transformation, and chemical balance. Their slow metabolisms and vast numbers shape global processes in ways that are difficult to measure directly. This makes the deep sea both an environment and an engine. Its extremity is not only about survival, it is about influence. Stability also affects how time is experienced biologically. Without frequent change, biological clocks lose relevance. Growth, reproduction, and aging proceed at rates dictated more by chemistry than by cycles. For some deep-sea organisms, a lifetime may span centuries. For others, development may take years before maturity is reached. This slow pace contrasts sharply with the urgency of surface life. In space, human missions are measured in days or months. In the deep sea, biological processes operate on timescales that dwarf human planning. Recovery from disturbance may take generations. This temporal mismatch makes conservation difficult. Damage can occur quickly, but healing is slow. A single mining operation or trawling event can disrupt ecosystems that took thousands of years to form. The deep sea does not respond dramatically to disturbance. It responds quietly over long periods, often out of sight. This invisibility adds to its extremity. We tend to fear environments that announce their danger. Explosions, radiation, vacuum. The deep sea is dangerous in a different way. It does not warn, it does not rush, absorbs. And yet life persists within this stability, not by adapting constantly, but by fitting perfectly. The deep sea teaches us that extremity does not always mean chaos. Sometimes it means stillness taken to its limit. A world where nothing changes quickly. A world where survival depends on lasting longer than everything else. As we move toward the final chapters, we will bring these elements together. Pressure, darkness, cold, isolation, energy scarcity, and stability, and ask what they reveal about life itself. Because the deep sea is not just an extreme environment. It is a test of what life can be when change is rare, resources are limited, and the universe offers no shortcuts, and life quietly passes that test every day. Why the deep sea may be the ultimate test for life. When all the elements of the deep sea are considered together, its extremity becomes clearer in a way that no single factor can explain on its own. Pressure alone would be survivable. Darkness alone could be adapted to. Cold, isolation, or energy scarcity by themselves are challenges life has faced in many environments. But the deep sea does not offer these conditions separately. It combines them. Crushing pressure acts continuously. Darkness is absolute. Cold is permanent. Energy is scarce and unpredictable. Isolation limits interaction. Stability slows adaptation. Each condition reinforces the others, creating an environment where partial solutions are not enough. Life here must be complete. This is why the deep sea may be more extreme than space. In space, hazards are severe but discreet. Vacuum can be mitigated. Radiation can be shielded. Temperature can be regulated. Human technology can carve out small islands of habitability by counteracting specific dangers. In the deep sea, there is no single danger to block. Pressure cannot be shielded against easily. Darkness cannot be illuminated meaningfully. Cold cannot be warmed without constant energy. Isolation cannot be eliminated. The environment presses inward from every direction all the time. Life cannot hide from the deep sea. It must become compatible with it. This forces a kind of biological honesty. Structures must function under constant compression. Chemistry must remain stable at low temperature and high pressure. Behavior must conserve energy relentlessly. Reproduction must account for vast distances and long timescales. Nothing in the deep sea is accidental. Every feature of deep sea life reflects trade-offs refined over millions of years. There is little redundancy. There is little excess. Adaptations that are merely adequate are not enough. This makes deep sea organisms appear strange to surface eyes. Soft bodies, oversized mouths, elongated limbs, translucent tissues. These are not curiosities. They are solutions. Solutions to a world that offers no forgiveness. The deep sea also tests life in a philosophical sense. It forces us to confront assumptions about what life needs. Sunlight, warmth, frequent interaction, and rapid change all feel essential because they define our experience. The deep sea shows that none of these are strictly required. Life does not need light. Life does not need speed. Life does not need abundance. What it needs is balance, energy gradients, chemical stability, and enough time for adaptation. The deep sea provides these in a way few other environments do. It is harsh but consistent, extreme but predictable, demanding but stable. This stability may be the key. In a world where conditions do not fluctuate wildly of Vertum, life can afford to specialize deeply. It can refine itself for a narrow range of conditions and trust that those conditions will persist. Space does not offer this. Space is empty, cold and exposed. Conditions can change rapidly near stars, planets, or radiation sources. There is little consistency, little shelter, and no medium to soften transitions. The deep sea, by contrast, is buffered. Water absorbs radiation. Pressure stabilizes structures. Temperature remains steady, change arrives slowly. This buffering allows life to exist at the edge of what biology can tolerate without being pushed beyond it. This does not make the deep sea gentle. It makes it exacting. The margin for error is small, but within that margin life flourishes in its own quiet way. The deep sea also challenges how we think about exploration. When we look to space, we imagine frontiers. We imagine expansion outward. The deep sea reminds us that some of the most extreme frontiers are beneath us, not beyond us. We have sent humans to the moon. We have placed probes on Mars. Yet the majority of Earth's deep ocean remains unseen. Its ecosystems are largely unmapped, its species unnamed. This is not because they are unimportant. It is because reaching them requires confronting an environment that resists intrusion at every level. Submersibles must withstand pressure that would crush most materials. Communication is limited. Light is swallowed. Movement is slow and costly. Every mission operates at the edge of engineering limits. The deep sea does not invite exploration. It tolerates it briefly. This reinforces its extremity. Space is vast, but it allows distance. The deep sea is vast, but it denies separation. You're always surrounded, always pressed, always enclosed. Many explorers describe the deep sea as more psychologically intense than space. In orbit, Earth is visible. Orientation exists. In the deep sea, there is only the immediate bubble of light and the sense of weight beyond it. This psychological pressure mirrors the physical one. It reminds us that extremity is not only about conditions, it is about perception. The deep sea feels extreme because it violates expectations deeply embedded in human experience. It removes light, compresses space, slows time, and limits connection. And yet life has adapted so thoroughly that for deep sea organisms, this world is not extreme at all. It is home. This is perhaps the most important lesson the deep sea offers. Extremity is relative. What overwhelms one form of life can sustain another. What feels impossible from the outside can be stable from within. The deep sea is not extreme because it is broken. It is extreme because it is precise. It reveals what life can become when shaped by consistent, unforgiving conditions over immense timescales. As we approach the final chapters, this understanding reframes the original question. The deep sea is not just more extreme than space in terms of pressure, darkness, or cold. It is more extreme because it demands total adaptation, and life, quietly and persistently, has met that demand. In the next chapter, we will bring this journey to a close by asking what the deep sea teaches us about life elsewhere in the universe, and whether the most alien worlds may not be distant planets, but environments already thriving beneath our own oceans. What the deep sea tells us about life everywhere else. When scientists search for life beyond Earth, they often begin with familiar assumptions. They look for sunlight, moderate temperatures, and environments that resemble the surface of our planet. These criteria make sense from a human perspective. They reflect the conditions under which we evolved. But the deep sea quietly challenges those assumptions. It shows us that life does not need comfort. It does not need familiarity. It does not need environments that feel safe or intuitive. It needs only a narrow set of physical possibilities and enough time for adaptation to do its work. The deep sea is proof. Here, life thrives without sunlight under pressure that would destroy most structures, at temperatures that slow chemistry to a crawl, and in isolation so complete that encounters between individuals may be separated by years. If life can exist here, then the range of possible habitats in the universe expands dramatically. Worlds once dismissed as sterile begin to look interesting. Moons with subsurface oceans locked beneath kilometers of ice. Planets with thick atmospheres and crushing pressure. Environments without seasons, without light, without obvious energy sources. The deep sea provides a working model for how life might exist in such places. Not energetically rich, not abundant, but persistent. One of the most important lessons from the deep sea is that life follows energy gradients, not light. On Earth's surface, light happens to be the dominant gradient. In the deep ocean, chemical gradients take its place. Heat, minerals, and pressure differences become fuel. This means that the presence of liquid water and sunlight is not the only path to habitability. What matters is whether an environment allows stable, exploitable differences, places where energy can flow slowly and predictably. The deep sea also shows that stability can matter more than abundance. Many surface environments are rich in energy but highly variable. Droughts, storms, temperature swings, and ecological disruptions are common. In contrast, the deep sea offers low energy but extraordinary stability. Conditions change so slowly that life can optimize itself precisely. This trade-off may be common elsewhere in the universe. A planet or moon with a stable internal heat source and a thick insulating layer could host life for billions of years, even if conditions appear extreme by surface standards. The deep sea suggests that such environments may be not only possible, but favorable. Another lesson is patience. Life in the deep sea moves slowly. Evolution unfolds over long timescales. Change is gradual. This slowness is not a disadvantage. It is a response to scarcity and stability. In the search for extraterrestrial life, we often imagine rapid growth, dramatic signals, or obvious biosignatures. The deep sea reminds us that life can be quiet. It can exist without announcing itself. It can shape its environment subtly, rather than explosively. This has implications for detection. Life elsewhere may not produce strong atmospheric signals or dramatic surface features. It may be hidden beneath ice, buried beneath rock, or dispersed thinly across vast regions. Detecting it may require patience, indirect measurement, and a willingness to look where intuition does not lead. The deep sea also reframes how we think about intelligence and complexity. Complex ecosystems exist in the deep sea, but they do not resemble surface ecosystems. They are sparse, specialized, and slow. Intelligence, if it were to arise in such an environment, would likely look very different from our own. This challenges anthropocentric thinking. Life adapts to its environment. Intelligence, if it emerges, will do the same. The deep sea encourages humility in how we imagine life elsewhere. It reminds us that our form is not a template. Even on Earth, life has explored paths we barely understand. There is also a deeper philosophical lesson. The deep sea exists beneath us, hidden, vast, and largely unexplored. It is part of our own planet, yet it feels alien. If such an environment can exist here, shaping life in unfamiliar ways, then the universe may be far richer and stranger than our surface-based intuition suggests. We do not need to look far to find the unfamiliar. It is already here. The deep sea blurs the line between the known and the unknown. It reminds us that extremity is not about distance. It is about conditions. A world does not need to be light years away to be alien. Sometimes it lies directly beneath our feet. This realization shifts the narrative. Instead of seeing Earth as a single uniform habitat, we begin to see it as a collection of worlds layered on top of one another. The deep sea is one of those worlds, a place with its own rules, rhythms, and forms of life. Understanding it expands our understanding of life itself. It shows us that life is not fragile in the way we often imagine. It is flexible, persistent, and capable of thriving under conditions that feel overwhelming. But it also shows us that life is precise. Deep-sea ecosystems are finely balanced. Their adaptations are exact, their margins for error are small. This combination of resilience and vulnerability is important. It suggests that while life can exist in extreme environments, it may not tolerate rapid change well. Stability allows adaptation. Sudden disruption does not. This is a lesson that applies both beyond Earth and here on it. As we search the universe for life, we must also consider how we treat the extreme life that already exists on our own planet. The deep sea is not just a model for astrobiology. It is a living archive of what life can become, and it is vulnerable. The same isolation that protected it for millions of years now makes recovery from disturbance slow and uncertain. As human activity reaches deeper into the ocean, the balance that sustained these ecosystems may be tested. This adds urgency to understanding the deep sea, not as a curiosity, but as a vital part of Earth's life system. The deep sea teaches us that extremity does not prevent life, but it also teaches us that extremity demands respect. As we move into the final chapter, we will bring these ideas together, not to conclude that the deep sea is harsher than space in every way, but to understand why it stands as one of the most demanding environments life has ever mastered. And in doing so, we may come to see life itself differently, not as something that survives despite extremes, but as something that emerges because of them. The quiet conclusion beneath the waves. When the deep sea is viewed as a whole, it no longer feels like a single extreme environment competing with space for severity. It feels like something more subtle and more revealing. It is not simply harsher, it is more demanding in a different way. Space removes life by subtraction. It takes away air, pressure, warmth, and protection. The deep sea overwhelms life by addition. It adds pressure, darkness, cold, isolation, and scarcity all at once without pause. There is no single challenge to overcome, only a continuous demand for total adaptation. This is why the deep sea may be more extreme than space. It does not allow partial solutions. It does not tolerate shortcuts. It shapes life slowly and completely, until survival is no longer an act of resistance, but a state of balance. The organisms that live here are not visitors. They are not enduring hardship. They are not surviving against the odds. They are precisely tuned to a world that never changes quickly and never forgives mistakes. This precision is what makes the deep sea extraordinary. Every trait reflects long negotiation with reality. Soft bodies that yield instead of breaking, slow metabolisms that stretch energy across decades, sensory systems that feel rather than see, reproductive strategies built around chance and patience. These are not compromises, they are solutions. Seen this way, the deep sea becomes a measure of what life can truly do. It shows that life does not require comfort or abundance. It does not need light or speed. It does not even need frequent interaction. What it needs is enough stability for adaptation to finish its work. The deep sea provides that stability in its most uncompromising form. Pressure does not fluctuate. Darkness does not lift. Cold does not ease. Isolation does not end. Time moves slowly, evenly, without punctuation. In this stillness, life has refined itself to a degree rarely seen elsewhere. This refinement is quiet. There are no forests waving in the current, no loud signals, no dramatic migrations, just persistence, just continuation. And this quiet endurance may be the most extreme adaptation of all. It also changes how we think about our place in the universe. We often imagine that the most alien worlds lie far away orbiting distant stars. But the deep sea reminds us that alienness is not about distance. It is about conditions. Worlds can exist on the same planet and still feel completely unfamiliar. Understanding the deep sea expands our imagination. It loosens the grip of surface-centered thinking. It prepares us to recognize life in forms and places that do not resemble our own experience. At the same time, it invites humility. The deep sea is not a challenge to be conquered. It is not an empty frontier waiting to be filled. It is an ancient system, finely balanced and largely beyond our ability to repair once disturbed. Its extremity is not a license for exploitation. It is a reason for care, As human technology reaches deeper, the choices we make will echo for centuries. The deep sea responds slowly. Damage lingers. Recovery is uncertain. What is lost may not return within any meaningful human timescale. This is the final contrast with space. In space, human presence is obvious and limited. In the deep sea, our presence can be invisible but lasting. The weight of our actions may settle quietly into ecosystems that evolve to withstand everything except sudden change. The deep sea does not ask to be understood. It does not announce its importance. It simply exists, shaping life beneath immense pressure, beyond light, and outside our daily awareness. And perhaps that is its most powerful lesson. Extremity does not always roar. Sometimes it whispers. Sometimes it lies beneath calm surfaces, enduring, adapting, and persisting without recognition. The deep sea is more extreme than space, not because it is more violent, but because it is more complete. It demands everything life can give and rewards it with continuity. In the end, the deep sea does not compete with space for our attention. It reframes what we mean by extreme. It shows us that life's greatest achievements are not always found where conditions are dramatic, but where they are unyielding. And in that quiet, crushing, sunless world beneath the waves, life has answered the challenge. Not loudly, not quickly, but perfectly. That answer has been unfolding for millions of years, and it continues, unseen beneath the surface, reminding us that the most extraordinary stories on Earth are often the ones told in silence. The long silence after understanding. After everything that can be said about the deep sea, there is still a silence that remains. Not because there is nothing left to learn, but because the deep sea itself operates beyond narration. It does not explain, it does not react, it simply continues. This silence is part of what makes the deep sea feel more extreme than space. In space, silence is expected. It matches the emptiness. In the deep sea, silence exists alongside life. Creatures move, feed, reproduce, and die in near total quiet, surrounded by water that absorbs sound and darkness that absorbs light. Existence here is not announced. It is implied. For humans, this is difficult to accept. We are accustomed to environments that signal activity. Wind in trees, waves on shore, voices, movement, noise. The deep sea removes all of this. It offers no feedback that life is present unless you look directly at it, and even then, only briefly. This absence of signals creates a psychological distance. It is easier to imagine space as extreme because it is visibly empty. The deep sea feels deceptive. From above, the ocean looks calm, reflective, almost gentle. Nothing on the surface suggests what exists beneath. This disconnect allows the deep sea to be forgotten, and yet it is always there. Beneath shipping lanes, beneath coastlines, beneath the places where human activity is most concentrated, the deep sea continues its slow processes. Carbon settles, nutrients cycle, life persists, the planet regulates itself quietly through mechanisms we barely observe. This ongoing process is not dramatic, but it is essential. The deep sea absorbs heat from the surface to buffering climate change. It stores carbon for centuries. It shapes ocean chemistry in ways that stabilize Earth's atmosphere over geological time. These functions do not require visibility. They require time. This brings us back to the central comparison with space. Space is extreme because it lacks time in a biological sense. There is no gradual adaptation, no slow negotiation between organism and environment. Conditions change abruptly and life must be protected artificially to exist at all. The deep sea offers time, not the fast time of surface ecosystems, but deep time. Time measured in millennia. Time that allows incremental change to accumulate into precision. Time that smooths sharp edges and refines survival strategies until they appear effortless. This may be the most extreme condition of all. A world where nothing happens quickly. A world where mistakes last. A world where adaptation must be exact because there is no second chance. Life in the deep sea is not constantly tested. It is continuously tested. There is no relief, no pause, no reset. Pressure does not lift. Darkness does not fade. Cold does not ease. Isolation does not break. And so life becomes quiet, efficient, and enduring. When we say the deep sea is more extreme than space, we are not ranking dangers. We are recognizing depth of demand. Space challenges life to exist at all. The deep sea challenges life to exist correctly. This distinction matters. It tells us something about the nature of life itself. Life is not merely a reaction to harshness. It is a process of alignment. Where alignment is possible, life settles in and refines itself until survival becomes stable. The deep sea is one of the few places where such alignment has been allowed to proceed almost uninterrupted for millions of years. That continuity is rare. It is also fragile. The deep sea's greatest strength, its stability, is also its greatest vulnerability. Systems that evolve slowly cannot respond quickly. Changes introduced over decades may echo for centuries. This is why understanding the deep sea is not just an academic exercise. It is a responsibility. Because extremity does not mean invincibility. It means specialization. And specialization means limits. As our technology reaches deeper, the silence of the deep sea makes it easy to forget consequences. Damage may not be visible, effects may not be immediate, but they will be persistent. The deep sea does not forget quickly. In the end, the comparison with space fades into the background. What remains is a recognition of scale, not spatial scale, but temporal and biological scale. The deep sea is extreme because it operates on a version of reality that humans are not tuned to perceive. It moves slowly, it speaks softly, it endures. And perhaps that is why it feels more alien than the stars. Not because it is farther away, but because it asks us to slow down enough to notice it. If you listen closely, there is no sound beneath the waves, only continuation. Life under pressure, without light, without urgency, without spectacle. Still here, and likely to remain, if allowed, the longest of all. The stillness that outlasts everything. At some point, comparisons stop being useful. Space and the deep sea no longer feel like competitors in extremity. They become mirrors, reflecting different truths about the same question. What does it really take for life to exist? The deep sea answers quietly. It does not offer drama. It does not present obvious danger. It does not shock with sudden violence. Instead, it presents conditions that never ease, never fluctuate, never apologize. And life, instead of resisting, adapts so completely that struggle disappears from view. This is the stillness that outlasts everything. In the deep sea, there is no triumph over nature. There is only alignment with it. Life does not push back against pressure. It yields. It does not conquer darkness. It ignores it. It does not escape cold. It slows down to match it. This approach feels almost philosophical. Where surface life is dynamic, responsive and expressive, deep sea life is restrained, economical and precise. It wastes nothing. It signals rarely, it moves only when necessary. In a way, the deep sea strips life down to its essentials: energy in, energy out, time passing, continuation. This minimalism is not emptiness, it is refinement. Every unnecessary feature has been removed by millions of years of selection. What remains works, quietly and reliably, under conditions that would overwhelm almost any other system. This is why the deep sea does not feel chaotic despite its extremity. It feels ordered. Pressure stabilizes structures, cold slows reactions, darkness removes distractions, isolation limits interference. Together, they create an environment where life can settle into long-term equilibrium. Space, by contrast, is unsettled. Radiation, micrometeoroids, temperature swings and vacuum create a world where stability is difficult to maintain. Life there must be protected, enclosed, constantly monitored. It survives by separation. The deep sea survives by immersion. This difference reshapes how we think about habitability. Perhaps the most enduring environments are not those that resemble our surface world, but those that remove variability. Worlds that are harsh but consistent, demanding but predictable. The deep sea is such a world. It is not friendly, it is not forgiving, but it is reliable. Reliability allows life to plan across generations, even when individual lives are sparse and slow. It allows ecosystems to form around rare energy sources and persist for centuries. It allows biology to explore solutions that would fail anywhere else. And it does all of this without ever being noticed. This invisibility may be the deep sea's greatest protection and its greatest risk, because what is unseen is easy to ignore. For most of human history, the deep sea was unreachable. Its isolation protected it, its extremity kept it intact, but that isolation is shrinking. Technology now allows us to reach depths that were once inaccessible. The same pressure that shapes life can now be resisted by machines. This changes the balance. The deep sea has never had to adapt to rapid change. It has never needed to recover quickly. Its systems assume time will always be available. Whether that assumption remains true is an open question. Understanding the deep sea as an extreme environment is not just about awe. It is about context. It reminds us that life can be both resilient and delicate. That endurance does not imply indestructibility. The deep sea has endured because it has been left alone. As we bring this journey to a close, one idea remains. The most extreme environments are not always the loudest, the brightest, or the most violent. Sometimes they are the quietest. Sometimes they are defined not by chaos, but by constraint. The deep sea is extreme because it demands total compatibility. It offers no exceptions, no pauses, no relief. Life either fits or it does not exist at all, and the life that fits has done so with extraordinary precision. Beneath the waves, under crushing pressure, without light, without urgency, without spectacle, life continues in its most distilled form, not rushing, not announcing itself, not asking to be seen, just continuing. Long after storms pass, long after surface worlds change, long after comparisons with space lose meaning, the deep sea remains, and in that permanence it quietly answers one of the oldest questions we ask about life in the universe. Life does not need comfort, it needs time, the perspective that changes everything. When we finally step back from the deep sea and look at it as a whole, something subtle happens to our perspective. The question is no longer whether the deep sea is more extreme than space. The question becomes why we were so quick to think of extremity only as something distant, explosive, or dramatic. The deep sea reshapes that idea. It shows us that the most demanding environments are not always the ones that overwhelm instantly. Sometimes they are the ones that apply pressure slowly, consistently, and without exception. The deep sea does not shock life into failure. It filters it patiently over immense spans of time. This filtering is quiet but absolute. Every organism that exists in the deep sea is the result of countless generations meeting the same conditions again and again. Pressure never relents, darkness never lifts. Cold never varies meaningfully, scarcity never disappears. There is no lucky season, no brief window of ease. Survival must be correct every day. This constancy is difficult for humans to imagine. Our lives are built around change. We adapt quickly because we must. We expect variation. We rely on it. The deep sea offers none. It asks life to settle into a single answer and hold it indefinitely. That demand changes how life expresses itself. There is little excess, little experimentation, little display. Traits that work are preserved, traits that do not vanish. Over time, what remains looks almost inevitable, as if it could not have been otherwise. This inevitability gives deep sea life its strange, almost sculpted appearance. Forms seem deliberate, even when they appear alien. Every curve, softness, and proportion reflects negotiation with pressure, energy, and time. Nothing here is temporary. This makes the deep sea feel older than the surface world, even though both exist simultaneously. The surface changes quickly, erasing its past. The deep sea accumulates history layer by layer, without interruption. In this sense, the deep sea is not just an environment, it is a memory. It remembers climates long gone. It remembers chemical balances that no longer exist. It remembers biological solutions that once spread across the planet and then retreated into the depths as surface conditions shifted. Life here carries echoes of earlier Earths. This is another reason the deep sea feels more extreme than space. Space is vast, but it is empty of memory in a biological sense. The deep sea is full of it. Its sediments, its chemistry, its organisms all carry records of survival under conditions that have remained harsh but stable for eons. Understanding this changes how we think about exploration. Exploring the deep sea is not like visiting a new place. It is like opening a book that has been writing itself for millions of years without interruption. Every observation is a glimpse into a system that does not reset between chapters. This continuity demands humility. We are visitors here, briefly observing a world that has no need for us. The deep sea does not respond to curiosity. It does not accelerate to meet us. It continues at its own pace. That pace is slow, and it is precisely that slowness that makes the deep sea so demanding. Life cannot rush solutions here. It must arrive at them gradually and commit fully. There is no room for half adaptations. This teaches us something fundamental about life. Life is not defined by its ability to survive sudden extremes. It is defined by its ability to endure constant ones. The deep sea is a masterclass in endurance, not through strength, but through precision. This lesson extends beyond biology. It applies to how systems endure, how stability is maintained, and how fragility can exist alongside resilience. A system can be robust precisely because it changes slowly, and it can be vulnerable precisely because of that same slowness. The deep sea embodies this paradox. It has survived asteroid impacts, ice ages, and mass extinctions, and yet it may struggle to cope with rapid changes introduced over decades rather than millennia. This contrast forces us to reconsider what it means to be extreme. Perhaps the most extreme environments are not those that destroy quickly, but those that demand perfection continuously. Not those that explode, but those that compress. not those that announce danger, but those that never stop applying it. The deep sea does not challenge life once, it challenges life forever, and life has answered not with force but with fit. As this journey comes closer to its end, what remains is not a sense of fear or awe alone, but a quiet respect. Respect for systems that operate beyond our instincts. Respect for life that does not need to be fast, bright, or loud to succeed. Beneath the waves, under pressure greater than we can easily imagine, life has found a way not just to exist, but to become stable. And in doing so, it has quietly redefined what extremity truly means. The extreme we were never watching. There is something quietly unsettling about realizing that the most extreme environment we know is not distant, not unreachable, and not new. It has been here the entire time, shaping life in ways we rarely acknowledge. While our attention has been drawn upward toward the stars, the deep sea has been carrying out its long experiment beneath us, unnoticed. This neglect is not intentional, it is structural. Human perception is tuned to surfaces. We build where light exists. We explore where movement is easy. We imagine danger where it is visible. The deep sea violates all of these instincts. It hides itself beneath a calm exterior, revealing nothing of the pressure, darkness, and constraint below. From the surface, the ocean looks passive, but passivity is not absence. It is restraint. The deep sea is active in ways that do not announce themselves. Chemical cycles continue. Heat moves slowly upward from the planet's interior. Carbon is absorbed and stored. Life feeds, reproduces, and dies at a pace that does not align with human urgency. This mismatch of timescales is why the deep sea feels so difficult to grasp. We measure progress in years. The deep sea measures it in centuries. We react to change quickly. The deep sea absorbs change slowly. We notice events. The deep sea remembers processes. This difference makes it easy to underestimate. Space feels extreme because it confronts us immediately. Vacuum, radiation, and temperature extremes are obvious. They feel final. The deep sea feels forgiving by comparison because it does not destroy instantly. It allows entry briefly. It allows observation temporarily. But that allowance is conditional. Machines fail quietly, mere materials fatigue. Systems designed for minutes begin to break after hours. The deep sea does not attack. It waits. Pressure exploits the smallest weakness. Cold slows response. Darkness hides problems until they cannot be corrected. This patience is part of what makes the deep sea more demanding than space. Space does not wait. It kills quickly if unprotected. The deep sea gives the illusion of tolerance, then enforces its rules without exception. This is reflected in the life that exists there. Deep sea organisms do not rush. They do not waste. They do not rely on chance bursts of success. They operate within limits so strict that inefficiency becomes impossible. Their bodies, behaviors, and life cycles all reflect acceptance of constraint. This acceptance is not resignation. It is mastery. Life in the deep sea has mastered an environment that does not bend. It has learned to align so closely with its surroundings that survival becomes steady rather than dramatic. This is a form of success that surface life rarely needs to achieve. We tend to celebrate resilience as the ability to bounce back. The deep sea shows another form of resilience, the ability to never need to bounce back at all. Because nothing changes quickly enough to require it, this realization forces a shift in how we define extreme environments. Extremity is not always about how hostile a place feels at first contact. It is about how completely that place defines the rules of existence. The deep sea defines everything. It defines shape, speed, lifespan, behavior, and interaction. It allows no exceptions and no shortcuts. Life either fits perfectly or it does not exist there. This level of selectivity is rare. Even deserts, polar regions, and high mountains offer variation, cycles, and windows of opportunity. The deep sea offers none. Its conditions are continuous, uniform, and inescapable. And yet life has not only persisted, but diversified. This tells us something profound about the relationship between life and environment. Life does not always seek comfort. Sometimes it seeks consistency. Given enough time, even the most demanding conditions can become home. The deep sea is not extreme because it is chaotic. It is extreme because it is precise. This precision is what makes it vulnerable. When systems are tuned so closely to specific conditions, even small changes can matter. Shifts in temperature, oxygen levels, or chemical balance that seem minor at the surface can disrupt deep-sea ecosystems that evolved under narrow margins. This vulnerability is easy to overlook because it unfolds slowly. There are no sudden collapses, no visible disasters. Effects spread quietly through reduced reproduction, slower growth, and altered chemistry. The deep sea does not fail loudly. It fades. Understanding this reframes our responsibility. The deep sea is not an empty space to be used. It is a finely adjusted system that has taken millions of years to reach equilibrium. Its extremity does not protect it from us. It makes it dependent on restraint. As this exploration nears its end, one idea becomes unavoidable. The deep sea is not a rival to space in terms of wonder or danger. It is a complement. Together, they show the full range of conditions under which life can exist, from absence to excess, from openness to enclosure. But only one of them is alive, ancient and ongoing beneath our feet. The deep sea has been answering the question of extremity quietly for millions of years. It has done so without spectacle, without witnesses, and without pause. And perhaps the most extreme thing about it is that we are only just beginning to listen. The quiet measure of extremity. At the end of this journey, what remains is not a conclusion in the usual sense, but a recalibration. The deep sea does not ask to be ranked. It does not need to be declared harsher, colder, or more dangerous than space. Its extremity reveals itself only when we slow down enough to understand what it demands and what it sustains. The deep sea measures extremity differently. It does not overwhelm life with the sudden violence. It does not remove the basic conditions for existence all at once. Instead, it applies unbroken pressure, uninterrupted darkness, persistent cold, and long isolation, allowing no relief and no variation. It is an environment that does not test life once, but continuously. This continuity is the point. Life in the deep sea is not defined by survival against odds. It is defined by alignment with inevitability. Pressure will always be there. Darkness will never lift. Energy will remain scarce. Time will move slowly. Life does not wait for conditions to improve. It becomes correct for the conditions that exist. This is a quieter kind of extremity, but a deeper one. In space, life would always be temporary, enclosed, protected from the environment rather than shaped by it. In the deep sea, life is not protected from the environment. It is built by it. Every trait reflects long exposure to rules that never change. This makes deep sea life feel complete in a way that few other ecosystems do. There is no excess, no wasted motion, no unnecessary complexity. Everything serves endurance. Everything supports persistence. Even beauty, where it exists, is functional rather than decorative. This is not a failure of imagination. It is the result of time. Millions of years under the same conditions produce solutions that appear inevitable. They feel less like adaptations and more like conclusions. The deep sea is full of such conclusions, forms that seem as though they could not have been otherwise. And yet these forms are alive. They feed, grow, reproduce, and interact. They are not static, they are simply unhurried. Their world does not reward speed, novelty, or display. It rewards fit. This is what ultimately separates the deep sea from space. Space removes context. The deep sea enforces it. Space is emptiness. The deep sea is constraint. And life, it turns out, can thrive under constraint as long as that constraint is consistent. This realization expands our understanding of habitability beyond comfort. It suggests that life may be most stable where conditions are least forgiving but most predictable. Worlds that appear hostile may be more accommodating than those that change too often. The deep sea embodies this paradox. It is hostile to us but welcoming to life that belongs there. It is dangerous to enter but stable to inhabit. It is extreme but balanced, and it has existed this way longer than any surface ecosystem we know. As we end this exploration, the deep sea does not feel like a place we have conquered or even fully understood. It feels like a reference point, a reminder that our instincts about danger, comfort, and possibility are shaped by our own narrow experience. Beneath the surface, another logic operates. A logic where silence is normal, patience is essential, and survival means fitting perfectly into a world that does not adapt to you. The deep sea does not need to be more extreme than space to matter. It simply needs to be what it is, a vast, hidden environment that has quietly demonstrated the full depth of what life can become when it is given time, consistency, and no room for error. And in that quiet demonstration, it has already answered the question we began with, not loudly, not dramatically, but completely. Life does not fear extremes, it learns them. After the comparison ends. When the comparison finally fades, what remains is not a winner, but a lesson that feels deeper than contrast, till space and the deep sea stop being opposites and instead become two expressions of the same reality. Life does not belong to comfort. It belongs to consistency. The deep sea teaches this without argument. It does not prove itself through spectacle or danger. It proves itself through duration, through the fact that beneath thousands of meters of water, under pressures that never ease, life has not merely survived but settled into permanence. Not dominance, not expansion, just continuation. This continuation is easy to overlook because it is quiet. Nothing in the deep sea urges us to pay attention. There are no horizons, no colors, no obvious motion. From above, the ocean surface hides everything below it. The most extreme environment on Earth wears the appearance of calm, and yet beneath that calm, life is doing something extraordinary. It is living without relief. On the surface, even the harshest environments offer pauses. Night cools the day. Seasons rotate. Storms pass. In the deep sea, nothing passes. Conditions do not rotate. There is no reset. Life must be correct at all times, not just during favorable moments. This requirement reshapes what success looks like. Success is not growth. Success is not expansion. Success is not dominance. Success is fitting so well that survival becomes invisible. Deep sea life has achieved that invisibility. It has become so well matched to its environment that it leaves no trace of struggle. There are no scars of resistance, no signs of compromise, only presence. This presence challenges how we think about intelligence, complexity, and advancement. It suggests that progress does not always move towards speed or scale. Sometimes it moves towards stillness, toward reduction, toward exactness. The deep sea is not trying to become more, it is trying to remain. And remaining under such conditions may be the most demanding task life can perform. When we look outward into space, we search for signs of life that announce themselves, signals, atmospheres, movement. The deep sea reminds us that life does not always announce itself. Sometimes it hides so completely within its environment that it becomes indistinguishable from it. This is a different model of existence, one where survival is not visible, where endurance leaves no obvious mark, where success looks like silence. Perhaps this is why the deep sea feels more alien than space. Space is unfamiliar, but it follows simple rules. The deep sea follows rules that feel almost personal, rules that press inward, that require patience, that reward restraint. It asks life to give up urgency. It asks it to slow down enough to match the pace of the planet itself, and life has done so. For millions of years, without interruption, the deep sea has hosted ecosystems that operate on timelines longer than civilizations. They have watched continents shift, climates change, and species rise and fall above them, all while remaining largely unchanged. This endurance reframes our sense of scale. Human time feels brief, human concerns feel narrow. The deep sea exists on a scale where urgency dissolves, where problems are not solved quickly but absorbed slowly. In that sense, the deep sea is not just extreme, it is patient. And patience, when paired with pressure, darkness, cold and scarcity, becomes something formidable. As this story comes to rest, there is no final warning and no dramatic ending. The deep sea does not conclude, it continues. It will continue whether we observe it or not, whether we understand it or not. The only question left is whether we allow it the time it needs to remain what it has always been. Because the deep sea has already shown us what life can do when given consistency instead of comfort. It can endure almost anything. Quietly see. What remains when we stop looking? When attention finally drifts away from the deep sea, nothing changes there. No signal fades, no system slows, no acknowledgement is required. The deep ocean does not respond to observation, and it does not diminish in the absence of it. This may be its most unusual quality of all. It exists independently of being seen. On the surface, visibility matters. What we see shapes what we value shapes what we protect. The deep sea has endured largely because it has remained unseen, operating beyond the reach of daily awareness. Its survival has never depended on recognition. This independence is rare. Most environments we know are intertwined with human presence, either directly or indirectly. The deep sea has remained separate not by intention but by condition. Its pressure, darkness and depth have acted as a barrier more effective than distance, yet that barrier is thinning. As technology improves, the deep sea becomes more accessible, not more forgiving. Its rules remain unchanged. The same conditions that shaped life there for millions of years now shape our interaction with it. Machines must obey pressure, time must obey depth, mistakes remain irreversible. This is where the story settles, not in warning and not in triumph, but in awareness. The deep sea is not an empty frontier, it is a finished one. Its systems are complete, precise, and slow. They do not need to be accelerated, optimized, or corrected. They need to be left enough time to continue. Understanding the deep sea as an extreme environment reframes our relationship with it. Extremity is not an invitation to test limits. It is a signal of sensitivity. Systems that function under narrow conditions do not tolerate sudden shifts. Life beneath the waves has adapted to constancy, not disruption. And that adaptation has been successful beyond measure. The deep sea has outlasted ice ages, meteor impacts, and continental rearrangements. It has persisted through changes that reshape the surface world entirely. Its endurance is not accidental. It is the product of alignment so complete that survival becomes routine. This routine is easy to mistake for emptiness, but emptiness is loud. It echoes. The deep sea does not echo. It absorbs. It absorbs heat, carbon, time, and change. It absorbs attention when we give it, and indifference when we do not. It remains. In the end, the deep sea does not need to be compared to space to justify its importance. The comparison only serves to highlight what is already true. Extremity is not always about exposure or distance. Sometimes it is about depth, pressure, and patience. Sometimes it is about environments that do not change enough to forgive mistakes. The deep sea stands as a reminder that life is not defined by how dramatically it survives, but by how precisely it fits. Beneath the waves, life has fit itself into a world that never pauses, never softens, and never explains itself. And in doing so, it has quietly demonstrated the fullest expression of endurance we know, not through force, not through speed, not through visibility, but through time. And long after our attention moves elsewhere, the deep sea will still be there, unchanged, continuing its slow work beneath the surface, answering no questions, making no demands, and reminding us, without words, what true extremity looks like. The depth that redefines extremes. When everything has been said and every comparison has been made, the deep sea remains unchanged. It does not respond to conclusions, it does not shift under interpretation. It simply continues to exist under the same conditions that shaped it long before there were observers to describe it. This persistence is the final measure of its extremity. The deep sea does not overwhelm life with sudden impossibility. Instead, it asks for complete alignment sustained over unimaginable spans of time. It demands that life accept pressure as normal, darkness as permanent, cold as constant, and isolation as unavoidable. It does not reward clever escapes or temporary solutions. It rewards only those forms of life that become inseparable from their environment. This is why the deep sea feels more extreme than space in a way that is difficult to articulate. Space confronts life with absence. The deep sea confronts life with presence. Pressure presses inward. Water surrounds completely. Time stretches without interruption. There is no empty margin, no place to retreat, no moment when the environment loosens its grip. Life must exist correctly, continuously. That requirement reshapes everything. It reshapes bodies into soft, yielding forms that do not resist compression. It reshapes behavior into stillness and patience. It reshapes ecosystems into slow, efficient networks that waste nothing and expect little. It reshapes time itself into something that is endured rather than measured. These adaptations are not impressive because they are dramatic. They are impressive because they are permanent. The deep sea does not host life that survives against the odds. It hosts life that has removed odds from the equation entirely by becoming exactly what the environment allows. This precision is easy to miss from the surface, where change is constant and visibility dominates perception. We associate vitality with movement, colour and sound. The deep sea operates under a different definition. Vitality there is measured in continuation, in persistence without display, in stability without growth, in systems that function so smoothly they appear inert. This is the kind of extremity that does not announce itself. It does not need to. Its proof lies in duration. Millions of years of uninterrupted existence under conditions that never ease is not accidental. It is the result of life meeting the deepest possible constraint and finding a way to remain. When the comparison with space finally dissolves, what remains is not a verdict, but a reframing. Extremes are not always found where environments feel dramatic or hostile at first contact. Sometimes they are found where environments are unchanging, unforgiving, and exact. The deep sea is such a place. It asks life to give up speed. It asks life to give up abundance. It asks life to give up flexibility. In return, it offers continuity. That trade has been accepted by countless species generation after generation, without awareness of any alternative. For them, the deep sea is not extreme, it is simply reality. And perhaps that is the most important realization of all. Extremity is not an absolute condition. It is a relationship between life and environment. Where that relationship is stable, even the harshest conditions can become home. Beneath the waves, under pressure greater than we can comfortably imagine, life has found that balance. It has not escaped the deep sea, it has become part of it. And in doing so, it has quietly expanded our understanding of what life is capable of, not through conquest or expansion, but through perfect, patient fit. The deep sea does not need to be explored to be impressive. It only needs to be acknowledged, because long after our comparisons end, long after our attention moves on, it will remain there, silent, pressurized and alive, continuing its slow, uninterrupted existence in the most demanding environment Earth has to offer. When extremes become ordinary, there is a moment, after spending enough of his time thinking about the deep sea, when the word extreme begins to lose its meaning. Not because the conditions are no longer severe, but because severity becomes normal. Pressure, darkness, cold and isolation stop feeling like obstacles and start feeling like context. This is the final shift in perspective this deep sea offers. Extremes are often defined by contrast. We call something extreme because it differs sharply from what we know. But for life in the deep sea, there is no contrast. There has never been light. There has never been relief from pressure. There has never been abundance. There has never been speed. There is only what has always been. In that sense, the deep sea is not an extreme environment to those who live there. It is simply an environment, complete, stable and unquestioned. The adaptations we describe as extraordinary are, from within that world, just ordinary ways of being. This realization is quietly unsettling. It suggests that extremity is not a property of a place. It is a property of perspective. What feels impossible to us feels inevitable to life that has never known anything else. The deep sea did not become extreme overnight. It became extreme gradually as Earth cooled, oceans deepened, and conditions stabilized. Life followed step by step, never needing to leap, never needing to escape. This gradualism matters. Life was not forced into the deep sea by catastrophe alone. It adapted into it over time, refining itself as conditions narrowed. What looks like endurance is often simply continuity without interruption. This is very different from how we imagine survival. We imagine struggle, resistance, and victory. The deep sea offers a different story, one where survival is quiet alignment, where success looks like stillness, where endurance leaves no visible mark. This is why the deep sea feels so difficult to dramatize. There are no climaxes, no turning points, no decisive moments, just ongoing existence under rules that never change. And yet, this ongoing existence may represent the most demanding test life can face, not a brief exposure to danger, but a permanent condition that allows no mistakes. Not a sudden crisis, but a lifelong requirement to be correct. Space threatens life with instant failure. The deep sea tests life with infinite duration. This distinction changes the question entirely. The question is no longer which environment is harsher. The question is which environment asks more of life over time. Which environment requires life to become something specific and remain that way indefinitely? By that measure, the deep sea stands apart. It is not an arena of constant threat. It is an environment of constant expectation. Expectation that bodies will not collapse. Expectation that chemistry will remain soy. Expectation that energy will be conserved. Expectation that time will be endured. Life meets these expectations not by effort, but by design. And design, once complete, looks effortless. As this journey reaches its end, the deep sea no longer feels like a mystery waiting to be solved. It feels like a reference point, a baseline against which we can measure our assumptions about life, comfort, and possibility. It reminds us that life does not seek ease, it seeks equilibrium. Given enough time, equilibrium can exist almost anywhere, beneath kilometers of water, under crushing pressure, without light, without urgency. The deep sea has shown us this without explanation, without display, and without pause. It has not tried to be more extreme than space. It has simply continued, and in that continuation, it has quietly expanded the boundaries of what we thought life could be. Not by being louder, faster, or more dramatic, but by being exact, patient, and complete. That is the deep sea's final lesson. And it does not end. It remains beneath the waves, doing what it has always done, holding life in a form that needs nothing more than time. The depth that needs no witness. At the very end of this exploration, there is nothing left to compare, nothing left to prove, and nothing left to resolve. The deep sea does not arrive at a conclusion. It exists beyond conclusions. It does not change when we understand it better, and it does not become more real when we finally pay attention. It has always been there. This is perhaps the most humbling realization of all. The deep sea does not depend on discovery. It does not require explanation to function. Long before language, before science, before the idea of extremity itself, life beneath the waves was already aligned with conditions that never softened. Pressure was already pressing, darkness was already complete, cold was already constant, time was already slow. Life did not wait for permission. It did not hesitate. It adapted quietly and continued. When we call the deep sea extreme, we are not describing it as it is. We are describing the distance between its reality and our expectations. The deep sea feels extreme because it refuses to meet us halfway. It does not resemble our world, and it makes no attempt to. This refusal is its defining quality. It does not bend. It does not negotiate, it does not explain, and yet life has met it fully, not through dominance, not through spit, not through intelligence as we usually define it, but through fit. The deep sea is a place where fit matters more than strength, where patience matters more than adaptability, and where silence matters more than signal. It is a world that rewards those who can exist without asking for change. This is why, in the end, the deep sea feels more demanding than space. Space asks life to survive briefly under protection against immediate danger. The deep sea asks life to be correct forever. It offers no shelter from itself. Only those forms that belong can remain, and belonging here is absolute. There is something almost meditative about this realization. The deep sea does not rush, it does not escalate, it does not climax. It continues exactly as it has, indifferent to whether it is being watched or forgotten. In a universe that often feels violent, loud, and chaotic, the deep sea represents a different kind of extremity, one defined not by destruction but by persistence, not by spectacle but by stability. It shows us that the most challenging environments are not always those that threaten life immediately, but those that demand perfection slowly over time, without rest. And life has met that demand, quietly, completely, without witnesses. Long after our comparisons fade, long after our narratives end, the deep sea will still be there, unchanged in its expectations, unchanged in its conditions, and unchanged in its quiet support of life that fits its rules. It does not need to be understood to continue. It does not need to be admired to endure. It simply exists beneath the waves, under pressure, without light, with time. And in that existence, it reminds us of something simple and profound. Life does not need the universe to be gentle. It only needs it to be consistent. And nowhere on earth has consistency demanded more or given more back than the deep sea, the ending that never really ends. There is no true ending to a story like this because the deep sea does not resolve. It does not conclude. It does not change its pace to match our understanding. When attention moves on, when words stop, when explanations fade, the conditions remain exactly as they were. Pressure continues to press inward. Darkness remains complete. Cold holds steady. Time moves slowly without interruption. Life continues within these constraints, not as an exception, but as a result. This is the quiet truth the deep sea leaves behind. Extremity is not always an event. Sometimes it is a background condition so constant that it becomes invisible. The deep sea is extreme not because it threatens life loudly, but because it asks life to be exact forever. And life has answered. Not with resistance, but with belonging. Not with urgency, but with patience. Not with spectacle, but with fit. Long after comparisons with space lose relevance, long after curiosity drifts elsewhere, the deep sea remains what it has always been. A vast, pressurized, lightless world where life learned how to endure by becoming inseparable from its environment. Nothing about it is temporary. Nothing about it is rushed. Nothing about it needs an audience. Beneath the surface, beneath the noise of the world above, the deep sea continues its quiet work, holding life in balance, holding time in suspension, and holding a reminder that the most demanding environments are not those that destroy quickly, but those that require perfection slowly. And that is where this journey rests, not at a conclusion, but at a depth. As this journey comes to rest, there is nothing left to rush toward and nothing left to resolve. The deep sea does not offer a final moment or a dramatic conclusion. It simply continues, exactly as it has for millions of years, beneath the calm surface of the world we know. If there is something to take with you from this quiet exploration, it is not a fact or a comparison, but a feeling a sense that life does not always thrive through noise, speed, or expansion. Sometimes it thrives through stillness, patience, and perfect alignment with its surroundings. The deep sea reminds us that some of the most demanding environments are also the most stable, and that endurance does not always look like struggle. Often, it looks like calm continuity, pressure held, energy conserved, time allowed to pass without urgency. If you found this space peaceful, or if these ideas helped your thoughts slow and settle, you are welcome to stay. There are many more quiet journeys waiting, exploring the hidden science of the universe, the deep ocean, and the places where curiosity and calm meet. Thank you for listening, and for allowing your attention to drift beneath the waves. Wherever you are now, may the silence remain gentle and the night unhurried.